Okay, so we'll start with the technical session. Myself, Deepika Jain, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 8th International Conference on ICT for Sustainable Development, ICT4SD 2023, Goa, India. The 8th edition of this conference is being organized in a hybrid mode. The physical event was held at Goa on 3rd August, and the virtual event is being held on 3rd and 4th August. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presenters, and each presenter would be getting 8 minutes for their presentation and 2 minutes for any question and answers. And on 7 minutes, I will give a gentle reminder. Please, stick to the time frame. And I request all the participants, to stay with us till the end of the session. And if you have any query, you can just drop me a message in the chat box. And just before we get started, could you please tell me what is popping on the screen now? I am not able to see it. Okay. We have a session with us that is Bhargava. She has over 19 years of experience in teaching field in the field of computer science and engineering. She has completed her PhD from Hemachandra Acharya North Gujarat University, Patan. She is the member of Board of Studies at MDS University, Ajmer, Rajasthan, and Board of Studies in Computer Science and Engineering and IT at MJRP University, Jaipur. She is a vice member of Computer Society of India, member of ACM, that is Association for Computing Machinery USA, member of IEEE USA. I welcome you to the session, ma'am. Okay, so we should start with our first presenter.
Yes,
ma'am. Would you like to say anything about yourself?
Deepika, please, I'm not able to hear you. Could you please repeat?
Ma'am, anything from your side to say to the participants?
Okay, I wish each and everyone all the best and best wishes for the presentation. Shall we start, Deepika?
Yes, ma'am. Yes. Okay, do we have Harish Rathod with us here? Not yet, he had joined. And okay, let me check the other presenter. Nice. Just a minute, Harish Rathod is rejoining. Okay. Siddhant, are you here? Siddhant Priyadarshi?
Yes, I am here.
Are you ready with your presentation?
Yeah, I am ready.
Okay, so you can start sharing your screen.
Yeah, sure. Is my screen visible?
Yeah, it's visible now and you're audible as well, so you can start. Faster, please. Like we have parallel sessions continuously. So yeah, thank you.
Yes, yeah. So yeah, I'm Siddhant Priyadarshi. So along with my co-author Saroja V. Sidmal, I am going to present the paper design and verification of 5-stage pipeline architecture using SB verification methodology module. So my introduction is I did my BTech from Kelly Technological University and currently working under Samsung as a design verification engineer. So this is how my presentation goes, starting with the introduction, then literature survey, then problem statement, objectives, architecture, and what is verification and result and conclusion. Yeah, so why we need a 5-stage pipeline or any pipeline architecture? So basically pipeline architecture makes the design faster because if you look at a 5 stage pipeline architecture, so there, let's say there are two instructions coming. So first instructions are fetched at the first clock, and second instruction is fetched at the second clock. While in a non-pipeline architecture, once the first instruction is completed, then only the second instruction is fetched. That is after 5 clock cycles. So it makes architecture n times faster depending on the n stages of the architecture. So this is why pipeline architecture is needed, and why we need to do verification of the design. So any digital or MS design and log and single designs are made. There we cannot say that this design is bug free by making only 2 or 3 test cases. So we need a complete verification plan for it, which covers all the corner cases of the designs, and it verifies the possible results of that corner cases. So this is why we need verification. And the SB UVM is basically an hardware verification language, which consists of low level and high level language. Yeah, so in low level language, we can actually add and delay, we can write in logic, which act as an hardware itself. And for making all the test scenario run, we need high level kind of syntax also. So SV and UVM consist of all these things. So this makes our life easy to create a scenario with delays and whatever scenario we want to make. So this is why SVUVM is introduced. So these are the literature survey. Yeah, so our main objective of this project is to design a 5-stage pipeline architecture using a RISC-V 32 instructions ISA. So yeah, and then we have to verify using SB VMM methodology. So VMM is verification methodology module of system Verilog. So this is how a 5-stage pipeline architecture looks like. So we have the fetch stage in the start, where the instructions are stored in instruction memory, and these instructions are loaded into instruction register using a PC, which is a program counter. So being a 32-bit processor, PC increments by a value of 4, and depending on the branch index, branch conditions. So this having a pipeline processor has some hazards also. So there are branch hazards. So whenever branch condition comes, it takes another instructions to install until that PC is loaded with the new value. So that branch prediction is done in the fetch stage itself. So depending on the branch also, the PC plus offset value is also added. But initially it will be PC plus 4 because it's an 32-bit. So if you look at the memory structure, it will be 8-bit, 4 sets of 8-bit. So fetching a first location will be PC, let's say 0, then next location will be PC plus 4, which is fourth address of the memory. So this is how instructions are fetched and stored into instruction registers, and then these instruction registers are decoded in the second stage, where let's say if you have an immediate data, so data sign extended with I mean there it is of 12-bit in instruction register, so that has to be sign extended to 32-bit. So the 11th bit of the IR will be extended with the 11th bit till 32. So this is done, and the source registers and destination registers values are being taken in this stage from the register, and then that values are given to an execute state. So in execute stage, depending on the opcode and func3 and func7 value, which basically defines the functionality which has to be performed, whether add immediate or whatever. So it is decoded, and it is given to execute state, where these values are executed in the ALU, which is arithmetic logical unit, and then it is that results are passed to the next stage, memory stage. So there are two kind of operations here. Now one will be the execution of the data and address, and another will be just stored. So if we want to store the data to memory, we'll just simply pass the data from decode stage. If you look at my cursor, it will be simply passed to data memory and it will be stored into memory. Whereas the data which has to be loaded back to the register, the address is computed and given to memory, and that data is being given back to the destination register. So last stage will be write back, which means whatever value we computed has to be stored in a destination register. So it will be stored back to a destination register. So this is a 5-stage
Dear
pipeline.
presenter, you have 2 minutes left.
Oh, okay, yeah. So this is my verification architecture. So we have driver sequencer where we write the test scenarios, what all thing we have to pass. So in my case, I tried to mimic the instruction registers which are being stored in the instruction memory, with the PC being mimicked as same as the DUT. So DUT here is my 5-stage pipeline architecture, and here I have mimicked the same instruction registers and PC, and I tried to match the instruction registers which are being fetched in DUT as well as in my test bench. And I also written two codes to check the functionality of the DUT. So one was the hexadecimal conversion of decimal value 10, and another was a mod 5 counter. So these two values are being checked here. So if you look at the simulation of RISC-V architecture, there are three instructions, which was add x1 plus x3, which is 4, and x1 minus x3, which is minus 2, and then it is x1 into x3. So here, if you check the first instruction, which is 4, so this is written back to x0 register, and here x0 is multiplied with the x3. So hence the value of x3 is 3 and x0 is 4, which is updated by the first instruction. This value becomes 12, multiplication of x0 and x3. So this becomes 12, so which is C in hexadecimal, and this is the synthesized result of the design. So these are the instructions which makes two code, which is a conversion of hexadecimal value, decimal to hexadecimal, which is 10 to 16. And then this another one is mod 5 counter. So if you look at the logs of my verification environment, so here the instruction register is being matched with the DUT. So if you can see matched, it is written. That means our DUT is fetching the correct instruction registers as we expect in our test bench. As soon as the output are not same, the mismatch we can see in a scoreboard. So hence, once the 16 reaches in the count, the conversion is done, the 16, then the value will be matched in the scoreboard. And in the mod 5 counter, once the value reached 5, it will be matched, as you can see the last scoreboard. So this is matched here. So this shows that our duty performs correctly for this two code, and instruction registers are being fetched are also correct. And we did the coverage of the instruction what we passed. So we got 80% coverage of our code in our verification methodology. Yeah, so we were able to correctly verify the 5-stage pipeline architecture using our SPVMM test bench. And future scope could be we can include multiple BFMs, which are bus function modules, which act as a reference model to a design. So we can add different slaves to the duty, and that is basically our UVM test bench itself. So we'll be creating the BFM around the architecture to introduce more complex corner cases and all. So this is the future scope. Yeah, that's all.
Thank you. Thank you for your presentation. Any questions, ma'am? Okay, thank you. So we
sorry, Deepika, I was unmute, I think.
Okay,
so,
yeah.
Siddhant, it's a very good
Yes.
attempt. Your paper is very
Yes.
nice, and it is covering all the parameters. I just wanted to ask you, is this the part of your thesis? You are doing PhD?
Yeah, yeah, yeah.
So
It's
it's
a
a
part of my college thesis project.
okay. So this five-staged pipeline entire architecture is designed by you using this SP Verilog?
Yeah. So this five-stage pipeline architecture, this was basically an open source. So
Okay.
what I did here is I took the instruction set architecture of RISC-V and I tried modifying that. I tried modifying that architecture according to the ISA of the RISC-V. So there was some few changes in the design, which included Func 3 and Func 7 implementation. Like it introduces the more efficiency and computation of opcodes. So that is being introduced in this general five-stage architecture.
Okay, it's very nice because since I saw 80% accuracy is already given according to you. So it is going to be good. Congratulations,
Yes.
Siddhant. All the
Thank
best.
you. Thank you.
Thank you. Okay, so we'll move further. We have our next presenter with us, Harish Rathod. Can you hear me? Okay. So please fix your issue soon and come back.
Yes, ma'am. Yes, ma'am.
Yeah, you can hear me? You're
Yes,
ready
yes.
with your presentation?
Yes, I'm ready with my
Please
presentation.
share your screen. Please share your screen.
Is it visible, ma'am?
Yeah, it's visible. You can start.
Okay, so good morning, everyone. Myself, Harish Rathod. I am a research scholar of Gujarat Polytechnic Technological University, and my co-author is Dr. Sanjay Agal. And today I am going to present my paper, A Study and Overview on Current Trends and Technology in Mobile Applications and its Development. My paper ID is 274. So outline of this paper is the introduction and objective. Current trends and technologies are currently used in mobile application, a life cycle development of mobile application, and how much cost should be given for mobile application, and how much time will be spent for development of mobile application. Finally, I summarized my session. Nowadays, we all know that IT industry has going very fast because everyone using mobile phones for their daily uses, and most of the things are embedded in the mobile phones. And if you look at the early days, software systems are used only at some specific places like government office, research centers, and industry. But at that time, the software system can be accessed by using only desktop or laptop. So if we reach to end people or normal people, it is very difficult at that time. So because every normal people cannot afford to buy a laptop or computer, so that's why we are moving to the mobile phones. And from very short of span, a smartphones has introduced, and it is very cheaper or easy to use than conventional laptop or desktop computer system. So apart from phone calls, people are using the smartphones for learning to earning purpose. One can learn from mobile applications, and one can earning money from mobile applications also. So mobile apps fulfill daily needs of people like education, shopping, health, business, etc. So it is very important in our life, plays a very vital role in our life. So our main objective is understand the smartphone usage and mobile data. Second thing is understand current what current technology is used in mobile application, understand mobile app development life cycle, and understand mobile app development time and cost. Let's start with the current ancient technology. Under this topic, we'll discuss smartphone and mobile data usage, mobile operating system, social media apps, on-demand mobile apps, mobile health applications, augmented reality technology used in mobile application, and another is beacon technology used in mobile apps. So start with the smartphone and mobile data. Uh, the demand for smartphones are increasing from last 10 years. And one of the reason is smartphones are much easier to use as compared to desktop or laptop. So according to one survey, Ericsson Mobility Report, Indian peoples are the first rank to spend their time on mobile on smartphones. And one of the reason is population of India and the large number of youth peoples are in the India, and they are very sophisticated to use that technology. So this is one of the reason why Indian peoples are ranked first on spend time on smartphone. And second reason is worldwide the cost of smartphone is lowest in India, as well as data rate is also very lowest in India. So according to this report, worldwide data usage per month up to the 2021, uh, India per person 18 GB, 18.8 GB per month, and Western Europe country it is 11 GB per person, and North America it is 15.2 GB per person, and Middle East Europe country it is 18.4 GB per person. And why data usage is increasing? That one of the reason is work from home. We all faces the pandemic COVID-19. So in that followed by work from homes are very popular, and people doing their business from home also. Now if you look at the mobile application, without operating system, a mobile application cannot run. So mobile application can be downloaded from variety of app stores. And to access the different mobile applications, different operating systems are available in the market. And if you look at in the market, Android and iOS operating systems are widely used. And according to the survey report, Android and iOS operating system capture almost 99.30% market worldwide. So here I have some data, that is iOS application, it captures a 28.37 percentage market, Android 70.93 market, Kia OS 0.12, Samsung 0.36, and Windows 0.02. And this is the and that's why Android and iOS operating systems are most popular among the developers. We have seen most of the mobile applications are based on the Android and iOS operating system. Now there are according to use there are various categories of mobile applications. Here I am discussing some of the well-known category of mobile applications. So one of the categories social media mobile apps. So everyone using start with their morning with the social media application. Whenever people wake up and they see the social media to check the news and everything. So nowadays people refer to share their thoughts and experience to the social media app. And nowadays social media is also one of the biggest platform for digital marketing. It is one of the easiest way to reach the end people, because every normal people nowadays using mobile phones. And the trending features in mobile applications, in social media applications, has found that location based service, voice interface, live video streaming, money transfer, sharing pictures, and etc. These are the trending features in social media applications. And here I am describing some famous social media app based on their active user. So worldwide, WeChat having 1,251 active users, Facebook Messenger having 300 active users, Snapchat 500.
Dear presenter, you have 2 minutes left.
Okay, madam. So overall, WhatsApp having much more active users. Now, on-demand applications, after COVID, people are demanding everything on their doorstep. So in that case, on-demand applications are very popular. So according to survey, in 85 million US citizens are using minimum one on-demand mobile applications, and it will be grown up to $57.6 million. Okay. So trending features in on-demand applications are location-based service, payment method, order tracking, deliver status, social networking, and push notification, and chatbot. And in our India, there are some well-known on-demand mobile apps are Ola, Uber, Zomato, Swiggy, JioMart, Big Basket, etc. Another is health application. So one can monitor their health using health application. And the global market in the 2020, it was evaluated $24.93 billion, and it will increase to expected $314.16 billion. So this is the worldwide percentage of user in a country. So these are the list of some well-known worldwide health applications. Now, augmented reality. The augmented reality technology is now embedded in the mobile applications, and one of the biggest company, L'Oreal, provide the features in the mobile application, and this feature can help the customer to apply different hairstyle and makeup virtually, so that they can check how they are looking, and all these things. And Instagram, Snapchat check using a face filter, and navigations are also available in mobile applications. And beacon technology, it is generally used for marketing purpose. Okay. This technology growing very fast, and it is used IoT based technology. Generally, the purpose for is marketing purpose only. Now, mobile app development life cycle, it is quite similar with desktop application.
Please come to the conclusion. Okay. We have already late, sir.
Okay. So the conclusion is, from this paper, one can identify where they can start their business, and which technology they can be utilized. And we can see there are lots of mobile applications are available in the market, but they are not reliable or secure. So reliability is one of the biggest issue in mobile application. Thank you.
Thank you. Ma'am, any questions?
Harish?
Yes, ma'am.
Congratulations for this paper you have presented. I wanted to ask you, since beacon technology is IoT based, so I wanted to know the frequency, the range which beacon technology can use? Means what is the range? Because it is using IoT.
Yes,
So
yes, ma'am. It is
yes,
generally based on the Bluetooth. So
okay.
it is near about 200 to 1200 meter.
200 to 200.
100 to 10, 100 to 10
Okay.
meters.
Okay.
So,
Okay, Harish. So
thank
I
you.
think there is more scope on working on beacons technology.
Yes, ma'am.
Okay. Thank you,
And
Harish.
yes, and my primary goal is to estimate the reliability of mobile application.
Okay.
Yeah. Okay.
Thank you,
Thank you.
Harish.
Thank you, ma'am.
Thank you. Thank you for your presentation.
Yes.
We'll move further. We have our next presenter with us, Purani. Can you hear me?
Yeah, it's audible.
Yeah, you're audible, and yes,
Yeah.
you can start sharing your
Shall I
screen,
say
please.
this?
Yes.
Yeah.
Okay, Sahil, are you here? Sahil Kumar?
Yes, I'm here.
Yeah, see, you can start your screen while she fixes the problem.
Okay, sure,
Please share your screen, please, Sahil.
sure. Okay,
Purani, just fix your issue and come back next, yeah? Okay, she's...
okay. Someone is sharing, so
Yeah, Sahil, you start. Purani, just wait, come back next after his presentation.
Yeah. Okay.
Till then, please fix your issue. Sahil, faster, please.
okay, sure. So I guess my screen is visible to all.
Yeah, that's visible.
Okay. So hello everyone, I am Sahil Kumar. So I have graduated this year in computer science and engineering from Triple IT Ranchi, and currently working as software engineer in Info India. Okay. So my paper title is Prediction on Heart Disease with Machine Learning Methods and its comparison and analysis. Okay, so the other authors along with me are Savita Nandan, Nidhi Kushwaha, and Bharat Singh. So here is the presentation outline which we'll be going through. So introduction, problem set, motivation of the project, then the literary survey, data sets and their finding, pre-processing, then the approach which we have applied, and the conclusion and the future work. Okay, so here is a quick introduction. So heart disease is one of the leading causes of death worldwide. Okay, so earlier detection of the disease is critical for effective treatment and prevention of complications. This project has developed and researched about models for heart disease prediction through the various heart attributes using machine learning techniques. So the problem statement for our project was like it is not possible to monitor every patient every day accurately. Okay, so can we predict whether a person is likely to have a heart strip or not? So the motivation behind our project was to save human resources in medical centers and improve accuracy of diagnosis. So this project aims to contribute to the development of an efficient and accurate model for heart disease prediction, which can assist healthcare professionals in making informed decisions and improving patient health. So here is the objective. So we have performed a data set exploration using various type of data visualization. The proposed work make an attempt to detect these heart diseases at early stage to avoid disastrous consequences. The project comprises of predicting the presence of heart disease using machine learning techniques and compare them. So we have investigated the state of various clinical decision support system for heart disease prediction proposed by various researchers using machine learning techniques, out of which we have taken a note of understanding of some of them. So here is the overview of it. And here is the approach method which we have followed through the project. So we have firstly analyzed the data, input data, then find the missing values if any. Then we have visualized the data. And then after cleaning, we have split the data into training and testing set. So training set will be used for training the model, and testing data will be used for the testing the model. Then we have compared the results of both. So here is the sample of data set which we have used. So we have sourced our data from Kaggle, and its size was 918 rows and 12 columns. So here is some insight about data. So our data set was nearly balanced. So we have selected the accuracy to be the evaluation criteria, as the both the negative and positive uh, parameters will contribute equally. So here is also some finding, like none of the column were attributes were having a null values. So we have applied reprocessing to enhance the accuracy of the model and acquire a data set free of null or missing values. And after which we have categorical inputs were converted to numerical using the level encoding techniques. Because method applied for training require numerical input with standardized attributes. For example, like fields like gender, which were having values male and female, were level encoded into numeric values in 0 and 1. After that, we used the box plots to detect outliers and remove them subsequently. So here is a sample of encoded data. Here we can see that the fields like sex, chest pain type, resting ECG, exercise engineer, and ST slope are level encoded. So we have used box loss as discussed earlier for detection of outlier and removal. So here we can see that observe that the age with less than 35 in the positive one is an outlier. Similarly, we can see for the other box plots. So here is the correlation matrix, and we can clearly see that no two attributes are highly correlated. So we have selected all the attributes for training our model. So we have splitted the data set into two parts as discussed earlier, like training set and testing set. And the ratio which we selected was 80:20. Also, the data was splitted randomly for testing and training purpose. So here are the algorithms which we used: logistic regression, random forest classifier, and support vector machine. So here is the quick overview of the algorithm. So logistic regression is used for predicting the categorical dependent variable using given set of independent variables. It is a probabilistic. It uses gives a probabilistic values which lies between 0 and 1. Based on the range threshold values lies, category of target variable is decided. So while training, it learns a set of weight or coefficient that describe the relationship between input feature and the log odds or logic of the outcome. Prediction, in predicting, it applies the learned weights to input feature and computes the probability of the outcome.
You have 2 minutes.
Okay, sure. Being one, using the logistic or sigmoidal function. The predicted outcome is then based on threshold values, so such as 0.5, that separates the positive and negative cases. So random forest classifier, it is an ensemble learning algorithm that combines multiple decision tree trained on random sample subset of training data and feature aggregate their prediction to improve the accuracy of the reduced overfitting. This result is generally mean or mode depending on the nature of the variable. The great number of trees in a forest lead to higher accuracy and prevents overfitting. So while training the model, it builds set of decision tree by random selecting a subset of training data and subset of input feature at each node of the tree. And while predict the binary outcome of new input, the random forest algorithm applies the trained decision trees to input feature and computes the mode of predicted class labels. The predicted outcome is then based on majority vote of the decision trees. So next algorithm was support vector machine. The goal of SVM algorithm is to create the best line or decision boundary that can segregate and dimension space into classes so that we can easily put the new data point in correctly category in the future. The best decision model is called hyperplane. SVM chooses the extreme point vector that help in creating the hyperplane. So while training data, SVM algorithm lowers a hyperplane that separates the two classes by finding maximum margin or distance between hyperplane and closest data point from each class. While predicting, the SVM algorithm applies the learned hyperplane to input feature and computes the sign distance or score of the input hyperplane. Input from the input hyperplane. The predicted outcome is then based on sign of the score. The positive score indicating the positive class and negative indicating the negative class. So here are the result of our analysis. So we can clearly see that the SVM and random forest are performing well in case of accuracy or other parameters too. So here in conclusion and future work of our project. So machine learning algorithms such as SVM and random forest have shown promising result in predicting heart disease and identifying high risk individual among the models we use. So the future work of the project can be enhanced by deploying the machine learning model obtained using a web application, and larger data set could be used for predictions. So here are some of the references which we have followed. Oh, thank you all for your time. That's all from my end.
Any questions?
Sahil, it's a very good paper, no doubt.
Thank you, ma'am.
So I just wanted to see the fields which you have taken in your data set.
Okay,
Could you please? Yes.
Let me share once again.
Yeah.
Okay. So here you can see the fields. Like.
Yeah. So apart from all these fields, you are taking ECG also. So how you are taking this data? Because these numerical values are written there.
Yeah.
Resting ECG. So medical imaging you must be taking.
Yeah, no. We are not taking the imaging. Like this data set was already present. Okay. So like here you can see the sample. Okay. So it was like categorical values. Like it is normal or ST, but to train the model, which we were needing the numerical value. So we level encoded that. Like numeric normal was given some value, then ST was given some values. For model, it is same. Like
so the entire data set you are taking from Kaggle.
Yeah.
Right. So no medical imaging you are taking for ECG.
No.
Okay then.
Like it was okay.
Yes, Sahil. So just wanted to ask you that.
Okay.
Right. Thank you, Sahil.
Oh, thank you, ma'am, for your time. Okay.
Thank you. So, Purani, are you here now?
Ready, ma'am. Ma'am, am I audible?
Yes, you are audible. Please start sharing your screen.
Yes, ma'am. Yes, ma'am. Sure.
Faster, please. Purani, just the Gmail page is open. Please fix your issue. We can't waste time like this. We have next session to do as well. Please fix your issue and come back. Surjot Saha.
Yes, ma'am. Am I audible?
Are you ready?
Yes, ma'am.
Yeah, please start with the presentation.
Is it visible?
Just a minute. Yeah, it's visible, sir. Please share your PPT. Yeah. You can start,
Yeah.
please.
So good morning, everyone present here. My name is Surojit Saha, and I'm a BE graduate from Tadomal Sani Engineering College. And the topic for my research paper is sign detection system. The other authors include Dr. Darshan Ingle, who was our mentor, Chintan Shah, and Farhan Sheikh. So we all know that majority of the accidents that happen on the road are caused due to drivers, because sometimes what happens is that they miss the traffic signs that are on the road, or they drive the vehicles on a very high speed. So traffic sign detection and recognition is very important to assist the driver in understanding the signs and following the traffic rules. So the objective is to identify and classify the traffic signs that are encountered on the road to provide correct information and to warn the driver about the traffic sign ahead using some voice-based recognition. So basically, there are three stages to implement the model. First is pre-processing of images to identify features, object detection and recognition, and the third is classification on the basis of deep learning. So we have done literature review. Basically, we have researched 3 papers, and according to the research, we have found that petabyte data was crucial for our project. So we went with the German traffic sign benchmark, which was taken from Kaggle. It contained 43 classes with almost 50,000 images. And during the review, we got to see many image processing techniques like HSV color space, Gaussian blur, etc. And the models previously used in those research papers were CNN, LeNet5, and Ensemble CNN. So the limitations of the existing model included that there were some images of daytime and nighttime. In daytime, the images were very bright, so the features would not be captured properly. And in nighttime, due to loss of brightness and contrast, the features wouldn't be captured. Uh, and voiceover, so the existing models did not have a voice feature that will tell the driver which sign is ahead. And during data augmentation, and like some images were incorrectly placed, so like if the data set is unbalanced or number is wrong, we use data augmentation. If we use the flip method, basically there is a left sign and we flip it becomes right, but the class label does not change. The class label remains the left only. So that was a major disadvantage. So what we have done is that we have done the image classification using CNN models like ResNet, BGG16 and 19. So since image classification was not enough, because there might be an image where there are many different traffic signs, so object detection is also very important. To overcome this, we used YOLO V5S model. V5S model because it is quite smaller and quite faster compared to the predecessor models. So for training the object detection, we used 743 images in GTSDB dataset, which had 43 classes. So the tools that we used was OpenCV to process images, TensorFlow and Keras for feature extraction and classification of image, and Google Colab for data analysis and implementing the model. So basically we had used the ResNet model, and the accuracy which came out to be 97.59%. VGG16 gave accuracy of 95.43 and 19 gave 77.32. So when we use the YOLO V5 model, we got the map value of 0.5. So yeah, this was my presentation. Thank you very much.
Yes, Surojit, again, it's a very nice paper I have come across in this presentation. So I congratulate for that. So you could have done and you can be done more in this field. So you have used YOLO, Google Colab, and I think OpenCV. So my suggestion is you can try to implement in in MATLAB also. So it is going to be good if you will incorporate your CNN. I think you have used CNN.
Yes, ma'am.
So
Yes, ma'am.
you could have implemented MATLAB also. So it's a good attempt. Thank you so much, Surojit.
Okay, ma'am. Thanks so much. Welcome.
Purani, you will have to do something because we can't waste time like this. Please try and then drop me a message if you're ready, and only then I'll allow you to present. Till then, Sumitra.
Yes, ma'am.
Yeah, are you ready?
Yes, I'm ready.
Yeah, please start sharing your screen.
Yeah. Ma'am, please confirm if you're able to see my screen.
Yes, I'm able to see your screen. You can start.
Yeah, I'll put it in the slideshow. And,
Yes.
all right. Yeah, good morning, everyone. I'm Sumitra. I'm presenting the paper along with my guide, Dr. Leena Raga ma'am. And our topic for today's presentation is user experience evaluation for pre-primary children using an augmented reality animal-themed phonics system. We are from Department of Computer Engineering, Ramravadik Institute of Technology, D.Y. Patil deemed to be University. So this would be the flow of our presentation. Introduction followed by motivation. Then we'll talk about the evaluation framework, what we designed, then the AR phonic system, and then the user experience results. Well, so we all know that the smartphones are being ubiquitously used in every household, and people are increasingly relying on these educational applications to simplify the learning process of their children. And this work is focused on creating a child-friendly framework which will evaluate the user experience of the pre-primary children who are aged between 3 to 5 years using an augmented reality application. So despite the rapid growth and importance of AR applications in various fields, providing the right positive user experience for primary students has always been a challenge. And if you can see in the past, children had limited access to technology, like computer, phones, or tablets, and they spent very less time using the technology when compared to adults. So as a result, what happened, the digital products and experiences, they were designed primarily only for adults, keeping only adults in mind. So however, this technology now has become very prevalent among the younger age groups also, and businesses must now get good experience to cater the children's needs also. And this animal-themed phonic application, we designed this application by keeping children in mind, especially age group of 3 to 5 years, and how to provide the attractive and user-friendly graphical user interface for children was our primary objective. And followed by that, in addition, calculating the user experience so was very tough because we did not have any reference point to calculate the user experience. So we designed our own framework and also put in some of the quiz features to evaluate the learning outcome of the children. So what was the primary motivation is we actually worked on evolving usability heuristics for AR/MR applications. So basically there we included the cognitive model of the users, and we spoke about the different levels of processing in human mind, and we designed certain heuristics and sub-heuristics for evaluating the applications. But then all those heuristics were aimed for age group, let's say a teenager and above, so 13 years and plus. So we thought that this technology should also reach the pre-primary children, primary children, and that should enhance their experience also. And heuristics will have to be defined for children as well, because the designers who design this, mostly they become the users also. Like if somebody is designing WhatsApp, they also become users. So they can very well relate it to it and then design a product. But if somebody is designing for children, they might not use that product, right? So when it comes for designing for children, it's very difficult for the designer to relate it. And giving a good guidance or having a good framework and designing the augmented reality technology for children is very important, because AR, MR technologies are non-traditional applications, whereas the other applications they are traditional applications, which people do have experience, and it's very easy to, the design theory is very easy to understand in the traditional applications. But when we say AR, MR, XR applications, they are all non-traditional applications, and it becomes very essential to understand the design theory behind the non-traditional applications, because these applications will consider the interface design, environment design, context of the users, and interaction design. So all put together will give a good user experience. So keeping this in mind, this was the motivation for us. And also we can see that in the past, children were not significant customers for the technological products because cost was high, or maybe difficulty in using the applications or the gadgets, and hence there was a lot of focus only on entertainment rather than educational applications. So now in today's world, we have seen that children use technology on a daily basis, and some children even use it more than adults. So this is the paper which we referred for this claim. Yeah. So with all this motivation, we started designing an AR, augmented reality phonics application. So we targeted the age group of 3 to 5 years, basically the pre-primary children, and kept the AR application very simple. And phonics is the first thing what the child learns in the school. So we thought we should have it we should focus on phonics, teaching phonics, and have a UI design which is user-friendly for children of that age.
Yeah, you have just 2 minutes left. Please conclude.
Yeah, sure. So this is a simple UI. There are hardly, only 4 to 5 clicks. And I would like to, since it's an AR application, I would like to run this application. So just to demonstrate, I have recorded this. And once we click on this, you can see the user interface is very child-friendly. And yeah. So like from A to Z, all the alphabets have been taken care, and we have designed it to teach. This is an animal theme, so obviously we have kept the animals. Suppose on tiger, we clicked on tiger. So this is the user interface. You can see we are scanning the AR plane in the classroom, and then the animal appears on the screen. So this digital 3D image is augmented in front of the real world. So they can scan it and then have a look at the animal. So it's very interactive. There is also volume. I hope you can hear the volume. So what is the sound the animal makes? And the description of the animal is also given. Yeah. Sorry. What happened? Okay. So I think I clicked on the next, this one, so it moved on. Yeah, very well. So that was the application. The animal appears, and as you can see, we just had only a very, very limited child-friendly user interface. And then how do we take the user experience? To measure the user experience, we use the emotions and the pictures of emotions like happy, shocked, afraid, content. Because for elders, we can say strongly agree, neutral, then disagree or strongly disagree. But it's very difficult for the students to understand all these metrics. So we just gave them these pictures and then asked them to rate it. And then round 1 and round 2, we did this as round 1 and round 2. And then we took the average of both round 1 and round 2. And then, yeah, so this is the result. We conducted this experiment with 20 students, and we found that why 20 students? Because, with 100 samples, there's a data which we found that the usability issues with 97% of the usability issues can be found with 15 users. So we did the study with 20 users because 98% of the usability issues can be understood. And then, yes, we did get a very good result for this application. And this framework helps us to measure the effectiveness or the user experience of children between 3 to 5 years. And the children were very happy. And moving forward, we are planning to also have some kind of environment of the wild animals and other things also to be augmented on the screen. Yeah. So these are the references. Well, so yeah, thank you. Hello.
Sumitra, it's a wonderful paper you have presented and a very good initiation also. So congratulations for that. Thank you.
Thank you. Thank you so much.
Thank you, ma'am.
Punita?
Yes, ma'am.
Yeah, are you ready now?
Yes, ma'am.
Okay. Please present your paper.
Ma'am, my screen is visible?
Yes, it's visible.
Good morning to all of you. Good morning to all of you. Myself, Punita, and I am a scholar in Manipal University, Jaipur, and my PhD guide is Sandeep Chaurasia, sir. These are the outlines of this paper. My paper is a review paper. So basically, the concept of this paper is previously model used for classification of knee osteoarthritis by using on the X-ray images or MRI images. So osteoarthritis is the most common form of arthritis affecting millions of people worldwide. It occurs when the protective cartilage that cushions the end of the bones wear down over the time. And osteoarthritis can damage any joint. This disorder most commonly affects joints in your hand, knee, and hips and spine. These are the stages of the osteoarthritis. First one is zero stage. Zero stage signifies no presence of osteoarthritis. And one stage means possible osteophytes, means extra bones create around the joint. Grade 1. Grade 1 is the grade 1 mean possible osteophytes, and second grade is definite osteophyte with possible joint space narrowing, means space between the joints. Grade 3 is a multiple osteophytes around the joint and definite joint space narrowing. Grade 4 is a severe stage in which surgery is required for the patient. This is the data description of my research. I have collected my data from the 2 different hospitals, and MRI images were collected, physically measured by the radiologist and senior doctor to provide the scale grading scheme. Images were divided into 5 levels, 0 to 4, and MRI images are collected the MRI images which are collected included left and right knee images. So we make a lab. So we consider one leg knee image and one left knee image, and we will take the mirror image of the another. This is a literature study selection. In the literature study selection, I have collected it. I have collected my papers from these sources, from PubMed 12 and Web of Science 40, Google Scholar 440, and Science Direct 50. So total, I have collected total number of paper 542, in which 45 papers separated because of repetitions. Next is number of articles separated according to keywords, 400. So 400 paper is now final, and then number of articles separated according to title. So final paper is 47. These are the keywords I have used for searching the paper: knee classification, knee osteoarthritis, knee X-ray, and severity. Literature review of this paper. The main work of this paper is the previously applied model for knee classification, knee osteoarthritis classification. The first author is Anatoni. He worked in the direction of predict knee osteoarthritis severity based on the scale grading. They applied a VGG 16 model and BVLC Cafinet and VGG M128 for knee osteoarthritis classification. Data description is total images is 8892, and source of the data set is OAI, and image type is data set type is X-ray. And the result of this mean square error 0.50. So we collected this type of result. Next author applied deep sequencing CNN model. His for the same direction, predicting knee osteoarthritis based on the scale grading. So I have collected all the research, previously research for the work in the previously work done in the direction of predicting knee osteoarthritis classification, predicting knee osteoarthritis severity classification based on the scale grading. So different model, different author applied and for a classification of knee osteoarthritis, and result of the author is providing this. So second one is applied deep sequencing convolutional neural network, and accuracy is 0.93. Third one applied VGG 19 model, and fourth one applied DenseNet model. Next one is some other authors applied classification model as well as object detection also for best accuracy. So they applied object detection for the separating the knee joint part, so that they can provide best accuracy for focusing only the part of the knee joint. So next one, apply ensemble DenseNet, and their result is sensitivity in case of normal, mild, 70.2, moderate 68.9, severe 86.0, and specificity in case of normal, mild, and moderate and severe. Next one is Kim Dong predict knee osteoarthritis severity based on Krell grading. They have applied CNN 6 since ResNet. The total number of data set is 4366, and they collected X-ray images from the hospital. So source is the hospital, and the accuracy is they provide accuracy according to individual Krell grading. So according to Krell grading 0, they provide the accuracy 0.97, and Krell grading 1 model providing the accuracy 0.85, and Krell grading 4 0.995. Next one is Tulip predict the knee osteoarthritis features and overall knee osteoarthritis severity. They applied ResNet 50 model, and they used 4796 images, total number of images, and distribution of training, testing, validation is this. The source is OAI and most. They have not mentioned. They have not mentioned here another model performance factor. Next author is Zhang. They worked in the direction of predicting knee osteoarthritis severity based on the Krell grading. They also applied ResNet 50 with CNN attention module, and they collected data set from the OAI, and data set type is a X-ray, and the accuracy is 0.74. So next one is Liu. This is the author. They work in the same direction, prediction of knee osteoarthritis based on the Krell grading, but they used faster CNN model for basically object detection, reasonable proportional, and the total number of images they use 54640. They collected data set from the hospital also, and this author is also applied faster CNN and VG16. Next one is Nalia. This author also applied YOLO.
Punita, please come to the conclusion.
Ma'am, conclusion is we have. I am working on this. Hello.
Yes,
Ma'am, conclusion is this. Now I am working on the ensemble model. I have applied ResNet 50, which is 19, and one more is AlexNet and CNN. But the ResNet 50 is given very much overfitting problem. So I am solving the overfitting problem, and now then I will apply ensemble model or stacking model on these models. This is the conclusion.
All right, thank you for your presentation. How many questions?
Yes, Punita.
Yes, ma'am.
It's a very nice paper, and as you have done the review.
Yes, ma'am.
And you have studied many papers. So
yes,
I just wanted to ask you, which is the best algorithm used by CNN for medical imaging?
Ma'am, recently I have applied for algorithm CNN, AlexNet, ResNet 50, ResNet 34. These are the pre-trained model. So ResNet 50 is giving very best accuracy, but my model is providing overfitting problem. So I am solving overfitting problem right now.
Okay.
And according to this review, ResNet 50 is providing best accuracy.
Okay. Thank you, Punita.
Thank you, ma'am.
Thank you for presentation. Priya?
Yes, am I audible?
Yeah, you're audible. Please start sharing your screen.
Okay.
Just a minute. Priya Raut, yeah? You're presenting a paper on real-time face recognition and counting.
Yes.
Thank you. You can start sharing your screen.
Okay, is it visible?
Not yet. Please start again. Please share your screen again. Yeah, it's visible now.
Okay. So our paper ID is 313 and the title of our paper is Real-Time Face Recognition and Counting. Myself, Priya Raut. My co-authors are Archana Chaudhary, Ravi Rathod, Divyesh Thakur and Shlok Agarwal. So the contents that we have covered in the PPT is introduction, literature survey, methodology, flowchart, following by result discussion and conclusion. Talking about the face recognition in crowded environments is a challenging task that has important application in various areas, as we know, in crowd management, attendance system surveillance, security. So there has been a significant amount of research focused on developing deep neural network based approaches for facial recognitions. So in this project, we explore the popular algorithm that works behind facial recognition technology. So the algorithm that we have explored is the Siamese neural network. So we have our results also demonstrate the performance of Siamese neural network in facial recognition and their potential for the practical applications. So the literature survey, so some papers we have referred. So occlusion, robust face recognition based on mask learning with pairwise differential Siamese network. So in this paper, competitive results of electronic equipments and real occluded face data suggest that the best of the plan is ability to the perform, so which is focused especially on the wide faces. Then the second paper that we have referred is using Siamese network with transfer learning for face recognition on small samples data set. So in this paper they utilize Siamese uh, comprising of two parallel CNN and utilize exchange learning of VGG16 demonstrate to perform confront acknowledgement. Um, then face recognition on convolution Siamese network. So this article also presents confront acknowledgement and profound learning approach with Siamese convolutional neural network in our framework. Then the last paper is differential morph face detection using deep Siamese network. So this was Springer publishing 2021. So in this paper, they ask for a deep Siamese mesh architecture to detect deformed faces. So talking about the methodology, so in the training part, an image can be paired up with the another image of the same label. So in our dataset, we label similar images with same labels. So making a positive pair or with the another image of different label making a negative pair. So this method generates two image pairs for each image in the data set. That is for each image it generates a positive pair and a negative pair. Then generating images for testing. We input two images from the data set to the two parallel networks which has a similar architecture. So these networks maps the embedded vectors from the data and it calculates the Euclidean distance and using sigmoid function it gives the similarity score. So our Siamese model predicts the similarity score of each test pair. Then this is the basic flow chart of the system. We generate image pairs for training, then training the model. Generating image pair for testing. So according to which we have done according to similarity score. So this, if the um, similarity score is high, then the similar images have high similarity score, and dissimilar images have low similarity score. So according to that, we test the model. Talking about results, so our model is counting faces in the frame as well, uh, for which we have used OpenCV. Then the proposed model gives value true as it recognizes the face 1, because we have feed the face 1 to the data set as the dissimilar face, which is given to our model to identify using Siamese network. So the key idea behind the working principle of Siamese network is to learn a shared representation for input data points that captures their similarity or dissimilarity, which enables the tasks such as verification, retrieval. Towards the conclusion, we have some conclusions that Siamese neural network is cutting edge algorithm that quickly and efficiently identifies differences between images. As the regular CNN would need a new model to be trained with new image data for classification. But in Siamese network, we don't need to retrain the model. It would be able to find the distance out between two unseen images as well. So during the implementation, we have found out that it is very expensive and time consuming, because training the model takes time and equipment as well. Then we have integrated with OpenCV to count the number of faces on the frame. So that increases application as well. So these are the references that we have referred. Thank you.
Thank you. Thank you for your presentation, Ria. Ma'am, any questions? Okay. Okay, so we have our next presenter with us, Pinna Murali Krishan. Who would be presenting a paper
Yes,
on
ma'am. Yes,
wireless room
yes.
surveillance system. Yeah.
I hope I'm audible to you perfectly.
Yeah, you are audible to me. You can start
Okay.
sharing your screen.
Yeah, ma'am. I'm sharing my screen. I hope my screen is visible.
Yes, it's visible. You can start.
Yeah. Hello, everyone. This is Binna Murali Krishna from Lovely Professional University. I'm a graduate from Lovely Professional University. And this is my project title, as you know, this is Wireless Drone Surveillance System. I have done it under the guidance of Mr. Dr. Shakiraj Chopra. And we have two group members. It's me, one of them is Murali Krishna, and another is Tarun Kumar. And so this was the content for today. It is introduction and components used, and system model and block diagram, and circuit diagram, flowchart, and result and discussion, conclusion, future scope of this project we are going to see today. And let me talk about the introduction. We are just using a microcontroller and some of the sensors in here, and buzzer and LEDs to just know the contents of the room. So for MQ2 gas sensor, MQ9 PIR sensors, and we are connecting it with the node MCU to connect to the, talk with the internet. It has a Wi-Fi module, so ESP to the double train to continue with the connection with there. So we are just using the buzzers. So if what you have done is like what you have done is like just connecting the sensors. Where we get the signal from the room, we have done we are thought for doing it for multiple rooms in a building, so we can automatically guess where the room things were going on. So we are connected for what you have done this prototype for only single things. So these are the components I have used: Node MCU, MQ2 gas sensor, MQ9, metal detection sensor, PIR sensor, LEDs, and buzzers. So this was the system model. So what you have done is in this project, you can see MQ2 gas sensor for domestic gas and HCF32 gas sensor for R32 refrigerant gas leakage. So this was the thing. So when we are using air conditioners in the room, we have seen some of the cases like where there is gas leakage in the air conditioners. So it was also a cause for that. So we have thought it would be a good thing if we add this one also. So we had added this. So metal detection sensors, when if the person entering the room is carrying another things like not perfect things like metal things like gun or something, so it will be detected by there. So PIR sensor just to detect the human presence in the room. If there is no human presence, we can just automatically say there is no human present in the security room. We have made that thing. So in this project, as you see, room a person entered the room, and all these things will be detected. And if there will be any of the fire or anything is detected, it will already breach will be detected in the security race, and it raises the alarm automatically. So, and we also done one thing like if there is no person in the room, we have to save the electricity also. So what you have done is whenever there is no person, the detection of PIR sensor, we will be raising the things that there will be no person in the room. You can turn off everything, turn off the electronic devices, the electrical devices in the room. So it will be for much far more better in there. So it will, we can turn off, or you can just give a signal in the security room to turn off the electricity. This was a mentioned block diagram in case of us. So may MQ2 gas sensor, PIR sensor, metal detection sensor. So these were the outputs with the buzzer and the LED, and the output on the cloud as well. So this was a suggested circuit diagram for us. The LEDs red, green, and blue. We are just noting the which type of things were active. If for MQ9, it will be red, MQ2 the green, and for the PIR, it will be mentioned with blue. So that case buzzer will be also active for them. And if the metal detection is done, the buzzer will be automatically raising the alarms. See, this was the flow chart we are mentioning. Detection and buzzer alert. Yeah. So this was the result and conclusion we are going with. In this project, yeah. Give me a second. Oh yeah. So we are using this ESP32 to raise the alarm. So when we're actually getting into the point, so sensors point, gas sensors more likely when there is more outcome of breach. If we can connect more of the devices in this case, so it will be like bigger chain, bigger rooms, and we can save a lot of electricity, and a lot of things can be controlled easily, and a lot of things can be known for the persons in the security room to help them in our case. So we made these things happen in our case. This was the conclusion. I would like to mention that we have used a lot of sensors. These sensors will, yeah, PSR sensors and these gas sensors machines gives powerful detection of cap potential threats. So this will be helpful whenever there is a off time for everyone. So we can, when there is certain things will be happening for unknown. So like in case of fire alarms, so we can see that human is present in the room. Human presence is there. So or else if there is any threat is happening, we can automatically know that this in case we are having this type of problems over here. So we can automatically judge them and get for the get for the help for them. In our case, we can automatically know without knowing for the any other human to enter there. In that case, we are going for that. And coming to the cloud, we are used for getting into the HTML part. We are used the HTML page to get into there, and we will search for the website name GoDaddy to get the DNS server, and we have to automatically, whenever the data is getting up, We will be just throwing up the data into the cloud, and it will be showing on the HTML page where we have seen the things. We can implement with the facial recognition of the people in the future, and smaller districts wireless cameras we can also include in here. So we can automatically send the data into the HTML page and display it on the HTML page. So integration with the IoT devices. So we can also connect the IoT devices like tube lights, fans, and things which can automatically get into the thing. We can on, turn off the things which already have, but we can automate those things with the LDR sensors, and we can automate these things with the future scope. Yeah, advanced wireless communication protocols, and we can 5G. There are a lot of things, and we can go into the things. We can throw it into the project, into the microcontroller, and attach them to go get into the room. That's all for the day. Thank you.
Thank you for your presentation so much. Thank you.
Thank you.
Okay, we have our next presenter, Purani. Purani. Ma'am, click on the Gmail and there's a PPT over there. You can click that, no? Yeah. Yes, your presentation is visible now. Ma'am, do it that way itself. No problem. We don't want that slideshow. You can use this. Yeah, this would work.
Yes, ma'am.
Yes, start please.
Yeah. And my topic is information system for neuropathy prediction, ensemble ranking in ordering clustering for diabetic healthcare monitoring. And this is the content of my presentation, introduction, and about diabetic neuropathy and related work, proposed work, conclusion, and future work. And let me give a small introduction about the information system. Nowadays, health information systems are prevailing everywhere in order to take care of the record maintenance of a patient. Whenever a patient record is maintained in a systematic manner with their diagnosis reports, medical reports, and vaccination reports and treatment reports, it is easy to monitor a patient regarding the complication of their disease. So in order to implement this, we have to go for an information system, which involves the information of each and every activity carried out by a patient. In case of diabetics, there are many people affected with chronic diseases. So monitoring of a diabetic patient becomes unnecessary. And let me introduce a small a brief about diabetic neuropathy. It is a disease of a nerve which damages nerves of diabetic patient when they are affected with diabetes. It is nothing but a high blood sugar which causes injuries in the nerve cells, which does not allow blood to flow frequently, or it causes a clot which affects the nerves of the system. It usually affects legs, feet, and hands. It can also affect other systems like digestive system, urinary system, blood vessels, and even heart. So, in case of diabetic, it is a very complicated disease which comes under microvascular disease also. So, in case of diabetic neuropathy, it is a major disease of diabetic complication which affects almost half of the diabetic patients. Once they become a diabetic, they must keep in control of the sugar so that they will not be affected with the disease. So, monitoring is an essential thing. This is a small report on diabetic neuropathy. A statistical report says people with age less than 40 are affected with 24%, and age group between 40 to 60 are affected 37%, and above 60 are affected 73%. So in case of diabetic, when people are more longer, the duration of diabetic matters for diabetic neuropathic progression. So certain kinds of works are done by several authors, in which they have summarized some of the factors which are responsible for diabetic neuropathy. So these are the literature surveys I have done for my work. The first work, which says the prediction factors are age, duration, gender, BP, lipid levels, and HbA1c levels. They have included many machine learning algorithms like SVM, random forest, logistic regression, and neural networks. In the second work, Malik and their co-authors have designed method for peripheral neuropathy prediction, and their factors include, and their major factors include that excessive intake of alcohol causes neuropathy in diabetic patients, and even it also causes heart disease. And in the next work, they have examined microvascular complication and have given out that machine learning and deep learning concepts work well. And in the fourth work, they have taken a serum cholesterol level and its effect with neuropathy, in which their predictions prove that serum cholesterol levels are much important in case of prediction of neuropathy. And in the last work, John Lowell and their authors and their co-authors designed a tree model to analyze the risk factors of neuropathic prediction in diabetic patients. And their factors conclude, and their major factors concluded duration of diabetics, HbA1c level, BMI, hemoglobin, and total cholesterol, hypertension, and fasting blood glucose levels, which are considered for the neuropathy prediction, out of which HbA1c, fasting blood glucose, and hypertension are strongly associated with neuropathy prediction. Summarizing all the related works, the proposed work is done to monitor the diabetic patients with machine learning techniques. At first, I have taken a dataset from Kaggle, which is a diabetic healthcare indicators dataset. From all the data sets I have collected, I have this is an unlabeled dataset. I have summarized the features which are only necessary for the prediction using k-means clustering technique, and then I have correlated the relations between the variables with the Spearman correlation. And this is a correlation matrix which I have got for my dataset. And the positively correlated features are taken for analysis, and the negatively correlated features are exempted out of the analysis. And proposed work says that k-means clustering has been done in order to take the features from the dataset with the help of Euclidean distance matrix. And a Spearman correlation has been done in order to find the distance and strength between the any two variables which are ranked in the clustering models. I have done the ordered clustering with the help of F-score analysis. This is the F-score analysis I have gained for my dataset. Depending upon the F-score analysis, ordering has been done, and the orders are concluded with 1, 2, 3, 4 patterns, in which the cluster order with the 1 has higher prevalence of a diabetic neuropathy prediction, and the order with the lower ranking has the lower prevalence of a prediction, and the cluster goes on like this. The first cluster has the data with the diabetics, BP control, cholesterol, BMI, smoker, and heart disease and physical activity comes under cluster 1. And second cluster includes cholesterol check, stroke, heavy alcohol. And the third one includes any healthcare conditions or comorbidities and difficulty walking. And the last order contains sex and age. So this is the pattern which we have to follow in case of diabetic patient monitoring. And the conclusion is that k-means clustering is coming out very well in this analysis. And my future work includes and collecting real-time data from hospital patients of neuropathy patients, and have gone analysis with a neuropathy doctor in order to collect information, and I am doing a information system in order to help the diabetic patients in order to come out of the complication in an earlier stage itself. If you have information system and provide them with the information to take care of the certain factors with the limited levels or limited features, then we can help them to go out of complication. So these are some of the references I have referred for my work. And thank you. Any queries?
Thank you. Thank you for your presentation.
Yeah. Thank you so much.
Thank you. Okay. Just a minute. So we have come to the end of the technical session. I sincerely thank all our authors and presenters for their excellent presentation and contribution in this session, and all our participants for being a part of this conference. I hope this session was informative enough. I, on behalf of the entire team, thank you for your support in the 8th version of this conference and all the previous sessions of this conference. I hope to see you in the next version as well. Just to inform you, all the presenters would be getting their certificates within 2 working days. Okay. and all the papers have already been forwarded to Springer Broad, and the publication will be live within 6 months. All right. So kindly cooperate with the team. I would request, I would also thank our session chair for chairing this session. Thank you for chairing the session, ma'am. This is from our side for you as a token of appreciation. Thank you so much.
Thank you so much, Deepika. And I'm so happy to be part of this 8th International Conference on ICT for Sustainable Development. So I congratulate each one for the presentation. Thank you, Deepika.
Thank you. I would request all the participants to just turn on their cameras so that I can take a quick snapshot. Okay, it's just 2 of us, all right. Okay, thank you so much.
Thank you,
Take care, everyone. Thank you.